Hi, welcome back to the breadboard. Got a new printer to have a look at. This comes as a partial to assemble kit in a nice big box. It's got sent to me from Tronxy, that's Tron XY to some of you, and they're not paying me to review this, but I do get to keep the printer, so just keep that in your mind up front. Be unbiased. It'll be what I think and not what somebody else thinks. This was sent to me with a caveat that it is an early release for my feedback to them and to show you what's happening. It's been a long while since I've reviewed a Tronxy printer. The first one and only other one that I've had is the X5S from quite a few years ago, and I've made many videos about that, and it's still going strong. And I've also included many upgrade videos that I've done over time. Difference being that that one is a Core XY kinematics, and this one is a standard Prusa style original 3D printer kinematics, where the bed moves in the Y direction and the X and Z are on the gantry that moves up and down. So anyway, it's a dual independent extruder model with a 300 by 300 by 390 printable volume. Based on the picture you can see here, it's got quite a nice layout. All the electronics seems to be included underneath the printer now instead of being off to the side and things like that. Can print in many different modes: mirror mode, duplicate mode, two color mode, etc., etc. We'll go through those in future videos. Today we're going to look at the build quality, how easy it is to assemble and get the initial calibration done, and probably a first print. We'll follow on with more different printing examples, leveraging the features that are available to it. It comes in a quite big box. It's too big to put on my bench, so I put it on the floor right now, as you can see right here. And let's go and get it open and see what's inside and see what we get for your money. Tronxy did send this to me free of charge on the condition that I at least do an assembly and review of the printer so that you can see and provide them some feedback. They've seen many of my videos before and quite trust my feedback to them as being some positive or negative, depending on what I find, but constructive feedback to help them make a better product. So that's what my intention is, and I'm going to share that with you as we go. Let's get the box. I'll get to the floor. I'll do the initial pulling everything out on the floor because there's not enough room on the bench. And then we'll look at assembling it and giving it a run. Okay, let's get started. All right, so as you can see, the box is pretty substantial. I already just quickly opened it up because on one end here, you can see it looks like it might have got dropped a little bit in shipping. So I just wanted to check that nothing was broken or anything, and it doesn't appear to be, so that's good. But I haven't gone any further than just doing that. So let's get in here and start pulling everything out. So top layer, two of the first obvious things. We've got a couple of small sample rolls of PLA, one blue, and this quarter of a kilogram, so 250 grams, and one in black. So we've got a blue and a black filament to some test prints. Little flaps, looks like they're hiding the two extruders, and just bits of packing foam. Here looks like we've got some bags. These look like they're vacuum bags. These would be for putting rolls of filament in. Not sure if Tronxy sell these, but we can check the website perhaps later. So that's good. Manual. Tronxy, if I remember rightly, did a very good manual in the past. It looks to be quite complete in English at the beginning for assembly, and also fault analysis, slicing, etc. We'll have a look at that as we go through. The print bed, it's got a protective cover on it. It's glass. It's got one smooth surface and a textured surface, which is nice. I've got that on my Aiwu 3D printer as well with a glass bed, and I think I've had one other one too. My first Tronxy had a fiberglass bed with a sticker on it. It wasn't quite so good. But this one looks much nicer. Everything there. Okay, we've got a kit of parts. We'll look at these on the bench in just a moment once I've got everything out. Little pump for those vacuum bags. USA mains cable. Take some metal brackets, not quite sure what they're for yet. Your standard bed scraper to get your prints off. 2 brackets for holding filament on your printer. Some spare parts, including 1, 2, 3, 4, 5 print heads, and a what looks like inductive sensor. And I think these 2 heads don't come out, they're included on the gantry already. So we lift out the top layer. Okay, so layer 2 is the main gantry, pre-assembled, including limit switches, etc. So that's just going to lift out. Let's just put that to one side for a moment. It's like one of the cable ties snapped in transit for one of the heads, but fortunately they were very well secured in the packaging. The second part is the main bed of the printer. That's quite heavy. A bag of bits here. Oh, that's a sensor just put in a bag. So we have the main bed, aluminum. Looks like it's about 3 mil thick. Just move that aside for a second and see if there's anything else in here. Oh, that's everything. So you can see packaging is pretty substantial. That's quite nice to see, especially when it's coming internationally. Put this back in. Okay, let's get the box out of the way and get back to the bench. Okay, let's have a look at what we've got. I've left the gantry on the floor on the side for the moment. I just want to show you the basically top layer components aside from the bed. So we have the filament holders, one for each side of the bed. These are not roller ones or anything like that. They're just bent metal. Will work for most things, but it might be something you might want to look at upgrading or printing your own and use bearings if you have any issues. But these usually will work fine with most filament rolls because they're plastic and they will slide very easily on it. So move those aside. We have a USB adapter to micro USB so that you can put your models on. It's going to have a manual in here. It's 8 GB in size. We'll have a look at that in a moment. We have a change that I've seen from original models of the printer. They have on the printer, especially previously, we just try and switch to the view. Okay, let's scroll down here. Originally, you can see them here. They mount either side of the printer. The early versions of the X5S had brass brushes in there. I don't know if you can see them on this or not. Let me just see if I can find an example. Okay, this is just a picture from one of the review videos that's on the Tronxy website, and you can see here on the left side that this is the nozzle cleaning that used to come with them, and it had these little brass brushes that the nozzle would wipe over and come back to clean the bristles, so clean the filament off the nozzle as you were running. And now what they've got is these metal wipes for the nozzles. I guess they're trying to improve how they work. Just going to go back down to where it showed the good picture of it. I'll point you to the website and you'll be able to look at these yourself anyway. So you can see a picture right here. So this is the new version where the nozzle is going to wipe and it's going to pull off any filament. This is going to be basically a cold piece of smooth metal, and it's going to wipe across and come back and get rid of any filament that's stuck on the bottom of the nozzle. So we'll see how well that works compared to, well, I don't have a brass brush version, but we'll see how it works anyway. All right, back to the parts. So we have a bag full of screw clamps. A lot of earlier printers, you would get what we call in North America and England and places bulldog clips, or at least that's what I call them anyway. And you would use those to hold the glass onto the bed. What they have now are small little clamps that will go under the bed. I guess they're lower profile and they just grip the edge of the glass to hold it down, which is a much nicer way to do it. You would have two on the front and two on the back. So, and they screw down from the bottom, so there's nothing to get in the way, or far less to get in the way of the print head, which is a nice improvement. It should work reasonably well. We have a nozzle wrench. We have a pair of, these are traditionally wire side cutters for electronics, but these are used to snip the filament basically, because when you're feeding filament through to load it up and things, you really want to have a nice clean end on it so it feeds easily. So that's what these are for. They're not terribly good if you try to cut wires with them and things. They're not always the hardest, but for the purpose that they've been provided for here, they're perfectly adequate. We've got a set of Allen wrenches, one with a decent handle on it, one with a screwdriver with a small tip, and we have a few smaller Allen wrenches as well. These are hexagonal ends on them for doing up the screws and things like that. We have the ubiquitous USB cable, spares. This one, we've got the 5 nozzles spare. I called them hot ends before, but they're nozzles. Assuming they're all 0.4 millimeter, and we've got a spare end stop sensor with a pre-made end on it. We've got some smaller screws for mounting the filament wipe pieces, larger screws for mounting the gantry onto the base. So there should be at least 8 of them. There's 2, 4, 6, 8. Looks like nearer 10, so they've got a couple of spares in there. It's always nice. Some more screws for something yet, probably for mounting the left and right filament holders. We have our North American power cable. This will obviously be different depending on the region that you're ordering for, to make sure you pick the right option off the website. We have our spatula for basically a modified paint scraper or putty knife for removing prints off the print bed. The one thing to remember when you're using these things, because they are fairly well sharpened, is don't dig them down deep. Let me just change the camera. You can see better there. When you're removing filament, you want to have them low down, like as low as possible. Even just have your fingers on the edge. You shouldn't be doing it with a hotbed. To keep it low profile. That way you minimize the risk of trying to dig into the bed. You have it up like this, you're going to dig into the bed. And you're going to, at minimum, you're going to scratch it. This is a glass bed with a coating on. They call it lattice glass, is what they call it. You could use the glass, smooth glass side if you wanted that effect for the finish. But the lattice coating is probably like a PEI textured coating, would give you a higher bond surface, therefore probably better adhesion for a lot of different filaments. And you get a boatload of cable ties for tidying up cables. So that's all that came on the top layer. I mean, we've got the glass bed, of course, which we mentioned before. So this is the gantry, and the main bed of the machine is what was on the bottom layer. This is the aluminum surface, which has still got a protective coating on it. It feels like it's pretty well secured. We've got at the back of this, we've got 2 ribbon cables which come from the electronics box down here that are going to go and plug into parts on the gantry. So one for the left head, one for the right head, and the steppers, etc. This is a nice different way of doing it rather than lots of individual wires. So we've got one for the left and one for the right, as you can see. You can see at the back here we've got the Y-axis end stop. So we have the Z-axis end stop in this little plastic bag. That's going to get attached to the gantry once it's assembled. On the right hand side down here, we've got a cable which is going to be for the right side stepper motor for the Z-axis. And we've got, as I said, and in the middle sitting here, we've got a mechanical end stop for the bed Y-axis. Okay. On the front of the printer, we have our LCD display with a little plastic cover. Looks like that's been pulled off and put back on before. On the right hand side here, we've got our micro USB slot, a USB slot, a fused IEC mains connector with an actual on-off switch, which is nice. And we have a plate here, which I'm not quite sure what it's for. Maybe it comes off and adjusts. We'll see as we do assembly. On the other side of the printer, we've got again the plate for mounting, and we have a selector switch for what your region mains voltage is. Now mine has come set for 115, which is the correct for my region. There's a little slider in there. You just slide it across and you can change it to, well, that says 20 volts, but I'm sure that's meant to be 220 volts. Where's that little screwdriver? I will mention that to them. As I said, these are early versions. So go across there and it's 230 volts. That's just a 20 volt little. So anyway, we want 110. It says 115 on the power supply switch. That's okay. So that's the base. I don't know if there's anything underneath. Oh, we have a tensioner on the back for the belt tension, which seems okay at the moment anyway, but just a simple adjustment. I think you slacken the Allen key here first though, so that you can move it. And on the bottom, let's just gently tip it over. We have plenty of ventilation. We've got a fan. Let's take the... Okay, while we have this upside down, why don't we take the bottom cover off and have a look inside to see what this is made of. So I like the fact that it's got a solid metal chassis. Adds a bit of rigidity to the printer. Rubber feet. Are they rubber? Yep, they are. So looking at the paperwork, this appears to have, according to the website, a power out recovery capability, which would be really nice, and also filament out sensors on the gantry. We'll see that in a moment. So here's one gantry cable. All right, can see a lot better. Looks like there's lots of mounting points in this chassis for other options. Not exactly sure of the how nicely that fan is mounted on a single bolt hole. Looks like it would have been better mounted to the lid, but that would mean more having to disconnect things, I guess. It is on a socket. Let's get a closer look at this. So we have the bed motor here. Right, so you can see quite clearly here the large capacitor. This will be used as a backup for the power for a few seconds when the main power goes off, so that it can remember where it was and resume printing, I would assume. We've got a few heat sinks here. There's going to be a stepper controller going to each of these, one for each head. These run up to the external cables. We've got, it's running out to the bed. Oh, thermistor for the bed temp. Not BTE, it's B temp. So there looks like there's plenty of options for plugging additional things in here. The processor is an STM32F4 controller, so that's a full 32-bit ST microcontroller, which is really nice to see. So we should be able to get some very smooth controlling. I believe this also has TMC steppers in it as well for silent running. So they're going to be the TMC of some kinds, probably 2208s or 2209s most likely. They all have heat sinks over them, so I cannot see what type they are. If we can find the Marlin software, which by the way, this runs Marlin, have a full color display on it on the front as well. Yeah, so you can see the cable running up to the display. It's a touch screen as well. They've secured it down. You can see the mains input here. They've got plastic insulation on all input cables, which is nice. They've used red, black, and blue. And I think the blue one they've used is the ground, which is weird because the international standard for ground is usually some kind of green and yellow, or just plain green. But nevertheless, and we've got red looks like it's the live, and black for the negative. So I would say if you're playing around with the wiring in here, don't specifically trust the colors to tell you what it is. Look at the connectors and what it says on the connectors to be sure. And obviously don't operate with the mains plugged in. It's not a Meanwell power supply. That doesn't mean it's a crappy power supply, but it's not a Meanwell one. It's going to be adequate for the job. What power is it? One sec. Yeah, there's a label on this side. It's 24 volt 15 amp power supply, so you should be more than adequate for driving this printer. Looks like all cables that are exiting out of the printer at the various locations are cable tied for strain relief. The print bed, let me just turn it a little bit and adjust the camera, has a thermal sheet stuck to the bottom of it to try and keep some of the heat in. Spring retainers. It's using the standard V wheels in here. I don't know if you can see or not. Anyway, the standard V wheels. We've got eccentric nuts in here for adjusting for good fit. We've got our standard bed leveling nuts. Now there is a bed leveling routine in this, but we'll see. I can't remember what kind of bed leveling it's using, if any. That may be manual. And yeah, it looks like these are reinforcing plates for the gantry to go onto. And what else is there to speak of here? I think that's about it. So let's just get the cover back on and we'll continue looking at what else we've got. Okay, here's the part of the gantry right now. I'll zoom out in a second. So we have our extruder 1, extruder 2, clearly labeled. Bowden tubes and covered cables feeding into the head. They look like the traditional hot ends. They've got a little silicone booty on them. And I can't see too well in there at the moment because of the covers. There is no magnetic end stop or anything like that that I could see here. The cooling, you can see it on this one, it's the exact mirror on the other one, is via, for the part cooling, is via this side fan. It's going to blow down over the nozzle, so it's only going to be on one side. So you might see some artifacts if you're just doing single head printing. The other head obviously is blowing in from the other side. Now when you're using dual extruders, independent, you want them to be able to get as close as you can to maximize how much space in the width that you have available to you. When one of them is not being used, you can see here, it gets right out of the way so that the other print head can get right to the side, which is really nice. So you're maximizing your print volume. Let's get these back in the middle. The two heads are slightly different in the way they're mounted. The first one here, E1, is mounted on a plate, and there is a little eccentric nut here that you can adjust, which looks like it tensions onto this rail. Now this is where there's been a deviation from a lot of this style of printer. The bed and the Z-axis moves on V wheels, which is your typical configuration for a lot of 3D printers. Easy to get a hold of from Open Builds and various other places for spare parts, etc. But the print heads, which really, to be honest, are the ones that do most of the traveling and moving, the plate has a couple of ground rods. I don't know if they're stainless steel or something else. They feel like they have a slight oiled texture to them. And so we've got metal wheels. I don't know if I can show you that. Maybe I can. There you go. Now you can see there. So we've got a pair of metal wheels on the bottom and on the top to run against these rails. So we should be able to get a very accurate, minimizing any wobble of the heads and things like that, even through wear. Might result in slightly more noise because you've got metal running on metal, but it should help, I think, to give you a better print quality. You can see a better view of the heads here. I take the rubber booty off of one of them. So fairly typical of a lot of printers. It's the flat heatsink. Without taking all of this apart, I don't want to do that just yet. Let me see if I have a one I took off from another printer. One moment. Yeah, so here's one from one of my other printers. I upgraded it to an E3D Revo printhead as part of their beta evaluation program. So I have one, and I've been upgrading some of my printers to E3D V6 and or better printheads. So the ones that come with this are this style of printhead with a flat heatsink. Nothing wrong with it whatsoever. It's very common for a large range of printers, and you can, if you want to, upgrade to full E3D V6. With this printer you may have to make a few adjustments. Same as on my original Tronxy X5S, I upgraded that to a full-blown E3D V6, and I had to 3D print a few brackets and things to make it fit. If you felt so inclined, you could do the same for this if you wanted to. Anyway, that's the kind of printhead that is in here. The print heads are limited to 275 degrees centigrade. The print bed is, I think, limited up to 85 degrees C, which is enough to print most materials. There may be some upgrades available at future dates for high temperature printing. So there's probably PTFE tubes inside the print head, which is what usually limits you to the temperatures that you can print. I'm just trying to see if I can pull this print head apart and show you what I mean. One sec. Okay, so if you look at the print head, this sleeve pushes, it screws all the way up to the top of there, as you can see. And when you put the Bowden tube in here, it actually slides all the way down into just above and hits the top of the print nozzle. So if you go too hot, you start to break down the PTFE tubing. It will melt and it will cause clogs and toxic fumes and things like that, which is why the printer is limited to 275 degrees centigrade. If you want to do more, you need to have an all-metal hot end. So yeah, that's basically what you're restricted to. They're very easy to maintain anyway. You can take them completely apart, and yeah, normally it's running kind of like that. There is a screw here that secures it in place, so you have a little bit of a break between here. That's your hot end, that's your cool end of the hot end, and your filament would feed in through the top. Obviously, because we have two print heads, zoom out a little bit, we have to have dual extruders as well with their own stepper motors. There's the Bowden tube for each one coming out and feeding into these particular print heads. And if you also look here, if I can adjust the view to show you, what we have here is our extruder, and we have a filament release tensioning lever. This is to adjust the tension onto the filament as it goes through. But we also have a run out sensor here on each one. So if you do run out of filament, you can actually have it stop and prompt you to add more filament, or at least protect your print from being destroyed, because it would continue going and you wouldn't know about it till you got up the next morning. At least here it would be waiting for you to continue, and you'd have a chance of recovery. So there's two recovery mechanisms we've already seen right from the start, which is nice. Belt is probably going to need tensioning because there's a clip on it which is pulling it down. It may have stretched it a little bit. You probably just didn't tension it up tight yet. Get rid of that. That's where the other, yeah, that's pretty loose. Very loose, actually. That was not good. Okay, it's a little bit loose because of the way it was clamped. But ideally, it shouldn't need to do much of a job. The main reason for this being here is to keep the left and right Z-axis stepper motors from drifting apart. this would be, and because we have two independent stepper motors for the Z-axis anyway, this just makes sure they stay synchronized and reduces the chance of the gantry going askew due to other things. And I've had that happen on one of my other printers before, and you know, so once you've set it, you shouldn't probably have to adjust it anymore. But clamping over the belt is not really a good idea, because I think it might have stretched it a little bit. It is a bit loose now. I don't know if there's much I can do about that. But anyway, another thing to feed back to Tronxy about that. I think that's everything, because everything about one side is completely mirrored on the other side. There's one last thing. Okay, so what you can see here, this is one of the stepper motors. The other one's exactly the same. We have 4 holes for mounting, 2 on this side, 2 on the back here. And we have our connector for the stepper power drive from the controller to come in. And the other thing that you'll notice here is that they have solid couplings for the Z-axis lead screw, which is good. You don't want the ones with the little spiral on them, because they would allow you to have a bit of spring in them. The gantry is secured. I don't think it has anti-backlash nuts in. Now, that is not a bad thing, because you know, gravity is going to hold these down, and these heads, you know, they're not, gantry is not going up and down like a yo-yo. There's a lot of weight here, so I don't think it's really an issue that it's not got anti-backlash nuts on the Z-axis. You can see right here we've got our connector for the big ribbon cable to come up. That connects to our stepper motor, our hot end, our extruder, etc. So some of it's going to break out into this cable, which goes to the hot end. Some of it's going to this stepper motor, and some of it's going to this stepper motor. The other side, of course, has got the exact same arrangement. Okay, because you've got obviously two heads and 2 extruders. So I guess the next thing is to get this thing completely assembled. Okay, so assembly could not be simpler. On the base, we've got these plates on each side, one on the left, one on the right. We've got 4 empty screw places, and that is where the gantry frame screws in. There's 4 screws per side. We've got 10 screws. I've got 8 of them on here for use. And basically, we just bring up the gantry, straddle the printer. I gotta be careful here because I've got another camera up and in the way. And we need to screw this in. The main thing here is to align the gantry up with the 4 holes on each side. I struggle a little bit because my camera is actually just a tad too low. I've just twisted it out of the way for the moment. Take the screw. Now don't tighten them up initially, because you will want to check for square. If you don't make sure that the gantry is square to the bed, you're not going to get the best quality prints out of your printer. So there's 4 screws aside. Now just finish putting these in. They are a fairly snug fit. I'm just getting them in loose, and we'll see how much play there is in the bed. In the gantry. It's nice that all the tools are provided. We just put the other side in, and I'll be right back to you. So something that may be worth doing when you're just before you finish tightening up the screws on your printer is to take a square like this one, or a permanent square. This one's adjustable, and check the alignment both of the gantry left and right to make sure it's not askew. I'm just putting this up against the rail, and that looks very, very good. I can see an even amount of light all the way along it. Difficult to show on the camera. And you can check on both sides. It should be, obviously they should be parallel. The other one is to check for the alignment of the bed this way. Now, obviously putting the square on here is the most ideal thing, because you want it square with the bed. So you could try and do that, but you're going to have to go slightly off the bed to do it. Not ideal. And in this case, I can see that there's a gap down here. You can see it even on camera. No gap up here. And if I push this back, then I can eliminate that. So it tells me that I do need to push the top of the gantry back while I tighten those screws up so that I eliminate and make sure that the gantry is at a right angle to the bed. All right, so that's a nice. If you have it slightly tipping forward, it's not going to notice much for most smaller prints, but if you do a really tall tower, it would be skewed slightly toward the front, and you don't want that. So we need to make sure we have this to the back when we tighten everything up, so we know that it is square. Okay, so let me just tighten these up now. I've just done the left side. Let me just recheck that one as well. I did check it before. Yeah, that one actually needs to come forward just a tad and tighten up. If you can hear that scratching, that's my cat trying to get in. Okay, that's the left side done. Try and get the right side done now. So that needs to be pushed back, which tells me that there's a little bit of... In the scheme of things, 3D prints are not perfect by any means, but more than adequate for most jobs that you'd want to do with them. Excuse my head here. Back of my head, should I say? Okay. Just gonna let my cat in. Be right back. Guess he just wanted food. I'm going to turn my own picture off on here because you really can't see me anyway because of the gantry in the way. There we go. So this is this now screwed tight and lined up. That looks level. And that one looks level. So that's good. So that's all nice and skew. You could use a smaller protractor with a right angle drawing tool if you have one. They would all work good enough for what we're doing here. We're going to need to take this piece of plastic off of the bed. It's got some little nicks in over here anyway, so even if you wanted to leave it, which you shouldn't because it's going to get hot, you want to maximize the heat transference from the bed to the glass. Not finished assembling everything yet. Don't be thinking that this is actually a printing layer. It's not. This is just a protective layer on the aluminum bed while they do the manufacturing. Okay, whew. This actually has a very slight burr on the edge, so it's probably because it's been stamped out. Might need a little bit of deburring on that. Could be a little bit sharp. We'll see how well the glass fits. If it actually extends over the edge right to the very edge, the burr on the edge could be high enough that it actually stops the glass plate from sitting flush on the bed, on the aluminum, and if that's the case, it wouldn't transfer the heat as easily. So if you find that, you may want to rub just take an edge and deburr it, either a small file on lightly at an angle, just take the edge off, or a deburring tool, which I have. Just one sec, I'll get it. This is the tool I have. I bought it from the local hardware store. It's a deburring tool. It'll actually work with metal as well as plastics. I got this because of 3D printing, basically, because it's great for taking off a little bit of an elephant's foot or a brim or something like that on a 3D print. In this case, it would also work to just run along the edge and take that little burr off. That feels much nicer there. I have to go around the whole lot, so I'll just do that. So here's the glass bed sitting on top. In my case, it does go right to the very edge, so that's why I did use the deburring tool and just quickly run around the burr that was on the side of the aluminum plate. Easy to do. You could use a file, you could use a pen knife with a sharp edge and just scrape it smooth, whatever it takes. I will feed that back to Tronxy to maybe look at cutting them the other way up so that the sharp edges are at least facing down maybe. Here's the print bed. It has a little warning sign, hot surface, do not touch. The protected side has got a film over it. It's not to be left on. This is not the print surface. It's just a protective layer for manufacturing. The other side is just pure glass, nice and smooth. So it goes in the print bed. There are little marks where those clamps are going to go. So now we can take this off. The best thing to clean these print beds with is just warm, slightly soapy water. Even if you use like a glue stick to help bed adhesion, which with this kind of surface you shouldn't need to, it still means, you still really should just use warm soapy water. I sometimes will use isopropyl alcohol, but usually the best is warm soapy water. Dry it thoroughly, don't get your fingers on it, and the glass surface will adhere to most things. If you're going to print PETG, put a glue stick or something on the surface, because PETG and glass will bond so tightly together that you will literally run the risk of ripping a piece of glass out of the bed. And if you do that, your bed's thrown away and you have to get another one, or at least the glass print surface is thrown away. So yeah, PETG, beware. Alright, so where's our little clamps now? Surprised some of the printer manufacturers haven't done this. Alright, that's where they go. So that keeps it on nice and secure. End stop, which you can't quite see there. There you go. It's under here. You should hear that click when the bed goes to the back. It's there. Belt seems tight enough for now. The gantry belts, there is an adjustment for the gantry belts on the ends of the gantry. Up here, they can feel the tension of this belt right here. Just a little bit. Better. The other one is somewhere where I can get to that one. There. Underneath. That one already feels quite reasonably tight. So, I guess that's that. Next thing we need to do is put on the filament collectors. I guess they go on like this. There's self-tapped screw holes already there for them. Tapped screw holes already for them. Hit the right Allen screw. There's an Allen wrench for every one of these. Go on here. This one is going to go on right here. You got to get 2 screws in, so don't tighten them up right away. Again, there are spare screws, which is always good to see. So the must be going to push quite hard against these wiper plates. They look like they're a spring steel. Yeah, quite a bit of tension there to wipe them. And that's before they even get to the end stop, so hopefully there's no adjustment needed. I didn't see anything in the manual regarding adjusting them, so we'll see. Following the manual loosely. I mean, it's pretty intuitive to put this together, so I'm not looking at the manual for every step. There's only 8 screws for the gantry to go on. I added the bit about getting it square. That wasn't in the manual, but really it should be some mention of it. These are just shown as screwing in. The inductive end stops are already there. I see a lot of people calling these optical, but they're not. They're inductive. Either way, they're end stops and they're not mechanical. So that one should work for this head. Yep. Alright, so that's those 2 done and these done. We have the filament mounts. These mount into the T-slots. So the mounts for the filaments, like the one I'm holding here, there's a mirror on the other side, mount on the back of this vertical Z-axis, the T-slots. The T-slot nuts, I think they call them boat nuts in the book, are already fitted. Now sometimes the kit doesn't have these already fitted, and the idea is you line them up widthways with the direction of the T-slot, drop them in, and when you rotate the screw to tighten them down, they will rotate in the slot and lock into the grooves. Now I can't tighten this up without getting my head in the way, so I'll be right back. Okay, both filament holders are now in place. My microphone, as you can see, I'm zooming quite a way out, and people don't normally see all of this, but got the gantry in place. What else have I got? I've got the head screws left. I've got a few ribbon cables. We've got the connections at the bottom to make. So let's look down a bit. I need to clip the cable tie off of the cables here. So this one is going to connect straight into here. It's pretty obvious. There's only one place it can go, and that is right in here. And there we go. And the same for the other side, of course. It's exactly the same. Now the last thing, of course, is the two stepper motors. There's a small cable sticking out the back for each one that plugs into the stepper motor connector at the back. And I'm not zooming in for that, but it's pretty, it'll only go in one way, and there's an obvious place for it to plug into. So let's get that connected. Now the last thing, so I've just plugged in this one as well. The last thing to be connected up is the Z-axis end stop. So that's going to go on here. Same thing applies. You've got these little T-slot inserts, and they go vertical, and you just drop them in and then tighten them up. Now this is going to be fun adjusting this end stop, because you don't want it hitting anything, but you need to adjust it so that this is close to the bed, and then you would use the bed adjusters underneath here to finish the job off. So I'm going to set it a little high for the moment, because I don't want the print heads crashing down on the glass and breaking it. Okay, that's in. I guess we're at the point of powering it up and setting it up. Now this is where things will get interesting, because we'll have to home the first head and then adjust the second head to match the height of the first one. So this one is determined by the bed adjustments and the limit switch, and this one is merely adjusted via this adjustment screw up here. Slacken off a couple of screws here, you turn this knob, and you can adjust the height of this up and down so that you can match the exact same height as this one. And there is a procedure built into the firmware of this to do that. So let's get this printer turned around, and we'll do the first steps of getting it leveled at least.